Hi everyone, my name is David and today I'll be presenting my project which is detecting AI generated images beyond faces. In the phase 1 we use CIFK dataset which is less than 100,000 images with a pretty low resolution. The model was trained and using three different layers, first being the vision transformer, second being the frequency CNN, third being the fusion, and the fourth layer being the classification layer. In the training we got pretty good results in the phase 1 with test accuracy of 88.6%, test area under curve of 97.4%, and test loss of 0.266. In the confusion matrix we can say that the model could detect fake images far more better than the real images, which led us we can say that even the area under curve had a really good separability where the curve is far more away from the diagonal. In the phase 2 we moved on to a foreign synthesis dataset which was close to 159 GBs in the extracted from post extraction. The size increased to 300 GBs. For pre-processing this huge data, we created a function which extracted 1 lakh images with all, of course, all 20 classes, randomly selected 2500 real and 2500 fake images, which closed to about 10 GB of storage spaces. Here's the split function which we used, where we can see every classes have 2500 fake and 2500 real images, and the total separation overall class balance is 50,000 fake images and 50,000 real images. Here's the sample display of the data. Coming to the model architecture, in the first stream we use RGB stream, which processes standard color image. This stream is good at capturing high-level semantic content. Here we define the patch embed, which converts a 2D image in the form of batch, shape, height, and width into a sequence of 1D vector called tokens or patch vector, which follows this two process of tokenization and embedment. Coming to the transformer block, which is a fundamental that processes a sequence of images which is generated by patch embedment layer. The function is to exchange information with each other in the form of tokens. Coming to vision transformer, which is basically responsible for extracting features from standard RGB image, 2 pixels. Basically, it takes a complex image, boils it down to a single feature vector. That a classifier can use to make the final decision whether the image is real or fake, which uses two following processes of patching and embedding. Patching is nothing but large images cut into smaller non-overlapping pieces. Embedding is converting raw image pixel data into a single feature vector. Coming to frequency CNN, which is designed to look for artifacts and signatures left out by a deepfake or image generator model. A frequency CNN looks into a low-level texture of noise, shape, and edges. Coming to fusion head, the fusion head, it ties together both the branches of VIT and frequency CNN. Its main job is to coordinate between two streams and merge their distinct perspective. Then the model training was carried out over 20 epochs for close to 4 hours, and the model accuracy was achieved 67%. The classification report says that the model predicted images to be real, turned out to be true real of 70% of the time, and it also says that there is a bias towards a little bit of fake images, as also the confusion matrix says the same. The area under curve here, the orange line represents the random guessing threshold, which is 0.5. The blue line plots the rate across all the classification threshold. In our case, it is 0.74%. Here we can see that 0.5% is the threshold wherein the model randomly guesses. Here, this is the range where our model finds, which is moderately good with a good separation between them. F1 score versus decision threshold tells us how F1 score changes as you vary the decision threshold. We can see that the 0.4 is the best trade-off between the precision and recall, which means that the model is not very overconfident in deciding whether the image is fake or real. For concluding my project, the project met its main objective as a dual stream achieved a normal generalization of 0.74% area under curve and 0.72 as F1 score on a large and a balanced dataset. The goal was to develop a robust model which is capable of detecting AI generated images beyond just faces, which handle the real world scenario of JPEG compression, filters, and distortions. Additionally, we wanted to test the dual stream architecture combining VIT with frequency domain. In the phase 1 of testing, as we achieved an accuracy of 88.6% and an area under curve of 0.97%, which confirms the fusion of VIT and frequency CNN was effective. In the phase 2, the same architecture was designed and was tested on a large and more complex dataset. The model maintained an accuracy of 68% and area under curve of 0.74%, showcasing the core design and generalized reasonability, which is beyond just faces. Even though it's not perfect, it represents the proof of concept handled with multi-class and cross-domain balanced real and fake dataset. The limitations of the model really struggled with slightly visually complex texture-rich classes such as potted plant here with the accuracy really low. Some real images were misclassified as fake because of distinct sensitivity to the compression and visual noise. In these cases, which will be dining table and plotted class. The training was constrained to my hardware of 16 GB of MNS, which is metal performance shredders, limiting the model depth and batch size. For the future work, we can apply with high resolution input. Also integrate frequency aware normalization, which also known as FAN method, which will help to reduce overfitting to textures or colors. We can further move to constructive pre-training to improve the robustness, which teaches the model to bring similar looking images to one cluster and different looking images further away from the cluster. And then we can expand to social media filters for practical usage, real world usage. Thank you.